Hello, this is Brujo Benavides, and this is the pre-recorded version of a talk that we are going to give at the Erlang Workshop 2021 about the detection of Oxbow code in Erlang Codebases with the highest degree of certainty, a paper that was published by myself and Laura Castro from Universidad de Catalunya. So what is Oxbow code? Let me introduce you to that concept with an example. Basically, the idea is that you have a module like this that runs a function. Doesn't matter what it does. It just runs something, and that run function, that is the function that is exported, will eventually evaluate something based on a parameter. All right, and then there is a ticket in your company, in your work, and it requires that run function not always evaluates the param, but some percentage of the time to do some A/B testing or whatever. It's a kind of a real-life scenario, very simplified. So you go to your application and you introduce a parameter to sample the execution of run. So the sample rate with, say, a 50% chance of happening. In your code, you go and add a new test for this, one that says that if the sample rate is 0, the evaluation is ignored, and another that says that if the sample rate is 1, then the evaluation actually happens. And it happens properly given the parameter that you provide. So these tests, of course, fail, and to implement the code that makes them run, you do something like this. First, add a macro for the default sample rate, in this case, 25%, and then you retrieve that sample rate from the application environment. Then, instead of always evaluating the function, you introduce an intermediate function to maybe evaluate based on that sample rate that you retrieve from the application environment. That maybe evaluate function, as you can see here, it's very simple. If the random value it calculates a random value, and if it's over the rate, the evaluation is ignored, and if it's under the rate, the evaluation is performed as usual. So this works, the test passed, and everything is happy, and the time goes on, and eventually your boss is done with your A/B testing, so you want to remove the sampling, something like this. The same thing we did before, but now the other way around. We have to remove the code that we introduced to sample the evaluation of run, the function run. But this happens a long time after the initial implementation of the sample, and maybe it falls in the hands of a different developer, or maybe the same developer, but as I said, it's a large project. It happened a lot of time afterwards. You don't remember exactly what you did to introduce the sampling, so you have to read the code and start from 0. The code, remember, something like this. And the initial thing to do, of course, is to adjust the tests. So we remove the test for ignoring, because now it will always be 100%. It will always evaluate. And we remove the setting of the sample rate in the evaluate test, because it's not needed anymore. We are left with a code that fails sometimes, depending on the random value on maybe evaluate. And it fails because maybe evaluate has a clause that returns ignore. So we remove that clause. And removing the removed code from the screen, we get something like this. And done. The test passed. It always evaluates. And you submit your pull request. Somebody says, yep, that makes sense to me. And that's the end of the work. But as you can tell, here, because we are on the presentation, not in the real-life code, this is not exactly the same stuff that we had before implementing the sample rate. And that's because, for instance, we have two parameters here that are not used And somebody with a keen eye can figure out that these two parameters are not used in any clause, and this is a private function, so they are actually not needed, so they can be removed. But if you remove these two, maybe evaluate and evaluate are actually the same function, so you can just remove maybe evaluate with an arity of 3. And you have to remove it from the place where it's called. And as you can see here, where you are also removing computation, unnecessary computation, the computation of the random value. So you can simplify your code by doing this, and it will still be working and will still pass the test. But the compiler will warn you that sample rate, the parameter, is actually not used anywhere. So you can add an underscore at the beginning of the parameter to ignore it, or you can, again, realize that this function is actually not needed because you can remove the parameter since it's a private function, and then you end up with just evaluate. So you can remove all these things and just evaluate on the initial code. That's fine, but then the compiler will tell you that you're not using sample rate. So since you're not using sample rate, you don't need to get it from the application environment, and you can just call evaluate. Done. And that actually looks much similar to the original implementation. But the people with keen eye here will detect that there is a macro, there is a not necessary, not used macro here. There is, before our tool, before we created our tool, there is no way any tool in the Erlang ecosystem to tell you that this macro is unused, not the compiler, not any of the other tools. But if you look carefully, you can see, yeah, this is a macro here. Nowhere else it appears on the module, so we can remove it. So you remove it. But then you remember that you also added a parameter on the application configuration, the application environment. And this is very tricky because now you need to know that nobody else used sample rate anywhere else in the application. Since in general, you don't do that. You don't put just sample rate. You put a proper name to it, like sample rate for run or whatever. But in any case, it's not simple. But in this particular scenario, sample rate is not used anywhere else, so you can remove it. And if you do that, yes, you are back to the original code. But each and every one of the steps that I show you requires some knowledge from the developer that's doing them. They require the test to be properly written so that they will detect that you removed too much things. And in large projects, it's very difficult to be sure that you can actually delete those things. But we all agree that with less code, it's easier. When the projects have less code, they are easier to maintain. So we all aim for this kind of removal when it's needed. But we don't do it in general. And that's because, in the same example, you can see how, for instance, we don't remove the macro because we are not sure if it's used. In this example, it's very easy to see that it's not used. But in large modules or macros defined in header files or shared among different libraries on an umbrella project, it's not that simple. Or maybe this sample rate, we can remove it from here, but we don't know if it's used somewhere else. And how do we know if it's used somewhere else? Will you look for application getemp calls? That may work, but what if some place uses application get all emp and then uses the macro somewhere? It's not that simple, even using your best developer eyes. And this function here that has two unused arguments, it's fine because it's private. But what if the function is an exported one with two extra arguments? Can they be safely removed? Maybe it's a callback. Maybe it's a neath stub. So it's not that simple. In general, the problem is that we are not usually sure if this can be removed, and therefore we don't remove it. And that code is left there, and it does nothing for the system. It's unnecessary, and it only hinders maintainability in general. And for its relationship with Oxbow lakes, I will explain in a minute, it's called Oxbow code. So we created a tool to detect these pieces so developers can easily and confidently remove them and simplify their code. We call it Hank. So Hank is a River 3 plugin to detect Oxbow code instances. Oxbow code are the things that I showed you before, code that's left behind when some functionality is removed or some features are adjusted. And since the code doesn't run in the main production path, it's left alone, and it doesn't affect the code, but it affects the life of developers. These instances of code are similar to Oxbow lakes, which are formed when a river cuts from two meanders, it connects and left a lake outside that's no longer part of the river, but it's still there. Our goals when creating this tool were to make it extensible, so we find some instances of Oxbow code, but we left the doors open for others to find more. We wanted to make it accurate. I will talk more about it later. And configurable, so you don't need to worry if it detects too much, or if you want to ignore some of its warnings because it's something that relates to your style or your way of working. So what instances of Oxbow code we detected and we implemented? We implemented each one as a rule. So Hank runs multiple rules on your code base. Hank can detect unused record fields. So you have a record with multiple fields, but you're only using one or two of them. Hank can tell you that some of the fields in your record, you don't really need them. Hank can detect, as I showed you before, unused macros, so macros that are defined in header files or modules where they are not used anywhere else in your project. It can detect unused header files, so you have an HRL file, but you are not including it anywhere. It can detect unused configuration options, as I showed you sample rate before. It's tricky because, as I told you, it's not just a matter of finding where getM uses. So it has Hank uses a heuristic where it looks for the atoms in the code. So if you're using a configuration option and it is an atom, and that atom is not used anywhere in your application, it will tell you about it. It uses it can detect unnecessary function arguments, as I showed you before. It contemplates behaviors and NIF calls, and so other known pieces of boilerplate that you need, where you need to ignore arguments. But for the other functions, it will tell you where a single argument on a function is always ignored in all the getFunction clauses. It detects unused callbacks. This is a very opinionated rule where we assume that if you define a callback in a module, you are going to call that callback from within that module. As I told you before, if you don't follow this rule, you can just ignore this rule entirely. But if you create your behaviors, you define your behaviors in this way, Hank will tell you where you have unused callbacks. All the rules, like I say, are like this. They all have assumptions, and the assumptions are stated on the documentation for each rule. If that assumption is not met by your code, you can ignore the rule, and that's it. But if it's met, it will help you detect Oxbow code instances. So other ones are single-use header files. So Hank rule for single-use header files assume that if you have a header file, it is to share code between multiple places. So if you are only including it in one module, you can just paste the header content, the header file contents in that module, and that's it. And the same for attributes in header files. And you can create your own rules. You just have to implement the Hank rule behavior. The documentation for it is on the repo, but it's very simple. A function to analyze the abstract syntax trees of the project files, and a function to be able to ignore specific instances and specific warnings. But now let's talk about the most important part here, which is accuracy. So we wanted to give developers security when removing Oxbow code instances. So we all know that the ELISER, for instance, is never wrong. It may not report all the discrepancies in your code, but if it says there is a problem there, there is a problem there. You can be sure that something's wrong. Hank will work in the same way. Hank is never wrong. It may not report every single instance of Oxbow code in your project, but if Hank emits a warning, that thing over there is actually Oxbow code instance. It's unused. You can remove it or change it. This is our goal, and this is how we implemented every rule, by always falling into, erroring into the side of false negative. So there are no false positives. If Hank says that thing is unused, that thing is unused. And so we, with the tool in our hands, we decided to check to see if it's useful, because maybe we run this on our projects and we find no instances of Oxbow code, and so we created all these things for nothing. Well, we checked with 3 different repos. The first one was Erlang OTP, 2 million lines of code and 20 years of development, the largest and oldest Erlang code base. And as expected, we found tons of unused macros and record fields and function arguments and header files, etc., etc. We even found one piece of configuration that's unused. We also ran it on Kazoo, which is tricky because Kazoo uses Erlang MK, I think, instead of regular config, but we did some things there, and we ran the tool, and we found lots of macros and record fields that are unused, way less than Erlang OTP, but still. And then we tried on a project that I personally contributed to in the past, and I knew it was very carefully maintained with lots of code reviews and test-driven development and whatnot, the MUSE-IM project by Erlang Solutions. And still, we found unused macros, unused record fields, and unused function argument. So this, for us, proves the importance of having a tool like this one in our ecosystem. And now what? Well, Hank can serve as an inspiration. Hank can't work on Elixir or other Vim languages, but it can serve as an inspiration for others to implement these similar things. We found a couple of rules, but there are many more that can be found and implemented. And of course, there are lots of improvements to parsing, to improve performance, and to find more edge cases, etc., etc. So, with this talk, what do I want to tell you? Basically, we created a River 3 plugin. It's a static analyzer. It checks your Erlang code and confidently, accurately reports all the instances of Oxbow code there. Just go there, use it on your system, find the instances, and clean them up. Your fellow developers will help you. And that's it for me. Thank you very much. And if you're in your way out, if you can kill some dead code, that will help me a lot. Thank you.